Okay, alkenes. So alkenes have a double bond, and that's right. The numbering. So we always number with the lowest carbon possible attached to the double bond. So in this case, if we number from the left, we have bute 1N, okay, because the carbon is on the first. The double bond is attached to the first carbon. If we number from the other end, we have bute 1, 2, 3N. So we go with bute 1N. Alkenes are unsaturated; they don't have as many hydrogens as possible because of the double bond. The general formula is twice as many hydrogens as there are carbons, and we can have cyclo molecules as well, cyclic molecules. Cyclohexene is an example of that. Okay, properties are similar to alkanes. As the carbon chain gets longer, the melting and boiling point gets higher because the strength of intermolecular forces increases. They're non-polar and therefore insoluble in polar substances. They don't conduct electricity, and they have lower density than water, and so they float on top of it. Okay, they can form geometric isomers, which are cis-trans isomers. The requirement for a cis-trans isomer is that you have a double bond, which prevents rotation around that double bond. So that means we can have two versions. That we have to, for this to happen, each carbon on either side of the double bond has to have two different groups or atoms attached to it. See how this carbon has a CH3 and an H, okay, two different things. This carbon also has a CH3 and an H, two different things attached to it. So cis is when they're on the same side, and trans is when they are diagonal to each other. Similarly to alkanes, the complete combustion produces carbon dioxide, and complete produces carbon monoxide or just carbon. Right, a few different reactions. The most common reaction for an alkene is an addition reaction. We're reacting the alkene with a molecule, and that molecule is just simply added on to the alkene. The double bond breaks, freeing up two single bonds, and then the molecule can be added either side of the double bond. So this could be hydrogen, bromine, chlorine, water, or a hydrogen halide. These are all possible addition reactions. So if we add hydrogen, that's called hydrogenation, bromine, bromination, chlorine, chlorination, H2O or water, hydration to get an alcohol, and a hydrogen halide is a hydrohalogenation. So firstly, adding hydrogen, this is to reduce an alkane. So to go from an alkene to an alkane, it requires platinum as a catalyst, or nickel. I think it's supposed to be nickel or platinum, and heat and hydrogen gas. And the double bond breaks, and the hydrogen gas is added on. One hydrogen atom is added onto each carbon atom. Bromination or chlorination. The bromine reaction is really important, but let's just look at chlorine first. If we react with chlorine, we just get two chlorine atoms added on, so a dichloroalkane. This reaction with bromine water is red-orange, but if we react colorless alkene with red-orange bromine water, we get a colorless product. So it turns the bromine water from orange to colorless. It's an instantaneous reaction. It happens straight away, unlike with an alkane where it takes time and a UV catalyst. So it's a dibromoalkane is what we're ending up with. Okay, that's what it's saying here. So the bromination rapidly decolorizes the bromine to identify the double bonds. This helps distinguish between alkanes, as alkenes will decolorize bromine water much faster. With an alkane, it's a substitution reaction requiring UV light as a catalyst. With alkene, it's an addition reaction which happens immediately. So alkenes generally are more reactive than alkanes. Okay, another reaction is hydration. This is to produce an alcohol from the alkene. So we're reacting with water. We need dilute sulfuric acid as a catalyst. That's the most common condition, or there's this condition here. Usually dilute sulfuric acid. And basically we're just adding on OH to one of the carbons and H to the other carbon. Now this is where Markovnikov's rule applies. the rich get richer, okay, because sometimes there's more than one possibility. Like in this instance here, we've got carbons, we've got this a carbon on either side of the double bond. We could add the OH here and the H here, or we could add the OH here, or here rather, the OH here and the H here. Okay, so it could be either of those way around. And the major product we get by using the saying the rich get richer. Okay, so which of these carbon atoms is richer? Well, the one on the left is richer. So that carbon atom is more often going to gain another hydrogen atom. That's what we're showing here. So the major product is formed by this carbon, the richer carbon, gaining another hydrogen, and the OH joining the other carbon. The minor product would be the other way around, with OH here and H here. Okay, it also applies to hydrogen halides. Obviously, Markovnikov's rule doesn't apply if we're just adding like Br2, because if we're adding the same thing to both carbons, then it doesn't matter which way around we do it, it's the same. It's only when there's two different things being added, like H and OH, or H and, in this case, H and Cl, or H and Br. So again, in this case, the major product is going to be where the hydrogen joins the richer carbon atom. So that's this one here is the major product where the hydrogen joins this carbon, which is the richer one, and the Cl joins the other one, and the minor product is the other way around. Okay, oxidation is to produce a diol. So it produces a double alcohol, if you like. So we're just adding an OH on to both of the carbons either side of that double bond. Permanganate is the most common oxidant. I'm not sure if dichromate might be another possibility, but permanganate will definitely do it. Okay, we can form polymers from alkenes. So that's where, again, the double bond breaks, allowing single bonds to form either side of the carbon atom to form a long chain. So, for example, vinyl chloride, which is this monomer here. Okay, so the monomer is the individual molecule, and the polymer is the long chain that forms when the monomer double bond breaks and joins with the other ones next to it. So this is an example of PVC, a very common plastic. It's just, yeah, it forms from this monomer. Okay, so the reactions you should know with alkenes are forming an alkane by adding hydrogen, forming a haloalkane. That could be like a dibromo or a dichloro, or it could be from like something like hydrogen bromide or hydrogen chloride, forming an alcohol by reaction with water and sulfuric acid as a catalyst, or forming a dihalogen alkane like a dibromo or a dichloro alkane. Okay, and that's alkenes.